homework going?
My code doesn't compile.
That's the best kind of error to have. It will compile. It will work. It will work. Remember, there's a quiz this weekend. I think last weekend. Okay.
So when we're divided,
Yeah, so dividing and multiplying, we don't have divide and multiply instructions. And so long as you're dividing and multiplying by powers of 2, which is what you are, then you should. Any other questions? Okay, so this is roughly, I'm just backed up slightly where we were last time, but it's crowded over here. So what you see on the slide is focusing on the variable d, two different ways that in C you can declare an array, in this case an array of integers. Arrays in C can be arrays of anything. It's also true in Java. We'll see other kinds of arrays later. So we have this array. That's called the static array. It's static because the array itself is allocated statically. The bottom part of the slide shows an image of memory, with the memory address before the colon and the value of memory on the right of the colon, or a description of the values on the right of the colon. And so in this case, the compiler allocates the entire array. And therefore, the compiler knows the address of every element of the array. It knows the base address of the array, in other words. Of course, it wouldn't know the address, in this case, of piece of A. Right? Because it wouldn't know the value of A, because the value of A is dynamic. The other kind of array, what we introduced last time, and we'll spend most of today talking about, is a dynamic array. Now, there's something static about a dynamic array, and that's the variable d. So as you see on the right-hand side, the compiler allocates some memory. When we're talking about C executing on your laptops, for example, pointers are 8 bytes long. So it allocates 8 bytes because B is a pointer. And in C, you can make pointers of anything by just putting a star between the variable and the type. The type will tell you what is the type of thing that this points to. Initially, it won't point to anything. And then we'll dynamically have a point to something. We'll see later that this star actually belongs here, but for now, to reinforce the idea that the star is actually part of the type, which is true. I'm going to put it over here and later I'll show you that. And then when the program's running, at some point you're going to do this. You're going to say B equals malloc. And what malloc does is it goes to memory. So this is in memory, and that's in memory. And there's memory. So I mentioned that memory kind of looks like this. This is the image the compiler is creating. It has all of the statically allocated things. This is all the code. All the code is statically allocated. So the compiler knows the address for the instruction. And all of the static variables are statically allocated. So in here we'll find this entire array, or we find this pointer. And that's what gets loaded into memory. And there's a bunch of space that has higher addresses than this stuff. well, that detail doesn't actually matter. It's just important that there's a bunch of space that the compiler has not put anything in. And this is available for dynamic allocation. And we'll see that there's two different kinds of data structures that are built here by runtime support with the help of the application that's linked into the program that does dynamic allocation. And we're starting with the first one. So when you say malloc, this comes from a region of memory we're going to call the heap. Well, everyone calls it. So the heap is where all the objects are. So when we say new in C++, talked about last time how new really under the cover is called malloc. So the difference between C and C++ isn't malloc, it's the exact same thing. The difference is that in C++ you say new with a class name, and in C you say malloc and a number of bytes. So malloc is a lower level thing. You don't say how many bytes in C++. Why not? Because C++ new operator calls malloc, so it has to know the number of bytes. Why don't you have to say that when you write C++?
Because you need to reserve all that memory to have everything go into it at the to save that memory so you can put everything into that at the start.
We do need to know how many bytes. The question is, why don't you say how many bytes in C++?
Does it know based on the class?
Right, you give the class name, and remember the size of everything is static. So the compiler actually knows the size of every class. Think about that. Look at different classes to prove that's true. The compiler knows the size of every object that's made from a class, right? So the class, part of a class gives the template for objects. And that's statically known. So when you say malloc, when you say new, the compiler, the C++ compiler inserts a call to malloc with the number of bytes that it knows. It's a constant. So that's in there. And then so that's the first thing you don't do. The second thing that's different is that C++, when you say new, it calls the constructor function that initializes variables of the object. We don't have that in C. And then the third thing is that what you get back from new is a typed pointer. What you get back from malloc is untyped pointers, you can assign it to anything. Now once I've assigned it here, I said b equals malloc, I've created in the heap an array. And I say b equals. So malloc returns, it does the allocation dynamically. Quite like what the compiler does when it's running, but this is happening while your program is running. And then just returns an untyped pointer, so whatever address that is. So let's say it's an address 3000. So this is just a function call, and it returns a number, and it returns the number 3000. So what happens here, this becomes 3000. The value of b is an address. We're going to come back to that in a few minutes. The other point is that. So on the slide, I'm coloring static things red, dynamic things green. I use red and green here, but red and green ink on the whiteboard is invisible. But hopefully you can see a little black. Okay, so there it is. There's the array. So this is where we left off last time. On the left-hand side, there's the RTL for that statement. So the first line puts the address of A in R0. The second line goes to memory. So look at the right-hand side of the arrow. It goes to memory and reads what's at that address. That's the value of A now. So in the second line, after the second line executes, R1 is the value of A. Right, this dynamic value. Probably does not know. The third line puts the base address of B, something the compiler does know. It's just a constant, the number 2000. And then the third line uses the indexed form of store to copy the value of A, right-hand side, into memory. where that instruction executing the CPU computes the address at which to store those 4 bytes by taking the base address in R2, which is 2000, and adding it to the value of A, whatever that happens to be,